IWCS webinar series event is hosted by the International Cable and Connectivity Symposium. I am Ed Fenton, a cable industry advisor working with the IWCS team. As Sammy said, if you have questions, please use the Q&A box on the bottom right of your screen to post a question anonymously. If you wish to contact the presenter or IWCS after the presentation, you will be given the contact points at the end of the webinar. Please note that IWCS does not distribute the presentation slides from either our conference sessions or these webinars. However, please feel free to contact the presenter directly and they will respond individually to you. Today, we welcome Randy Ivins, Project and Program Manager of the Wire and Cable Division of UL in Melville, New York, USA. Randy will be presenting his paper on Raising the Bar on Patch Cord Performance in the Real World. Randy Ivins is a Program and Project Manager in the Wire and Cable Division of UL. He has been with UL for 40 years and is currently part of a team responsible for the development, implementation, and maintenance of various UL programs in the wire and cable market. Randy has served as chairman of the Telecommunications Industry Association TR 41.7 Committee, Environmental and Safety Issues, and is a contributing member of the TR 41.9 Technical and Administrative Regulatory Considerations that is responsible for the development and maintenance of ANSI TIA 1096-A. Randy was also recently the project leader for an investigation on power over local area network communications cables and authored the fact-finding report. Randy, we welcome you today to present at this IWCS webinar series event.
Good morning, good afternoon, good evening, everybody. This is Randy Ivins, and I'm going to be talking about patch cord performance and the real world. The agenda for today is going to be just a real brief introduction on patch cords, background of why we went in this direction, and what was the reasons behind looking at patch cord performance, problems that are out there with patch cords and possible solutions, the new outline of investigation for patch cords, which is looking to resolve some of those problems, what verification means with respect to patch cords and modular plugs, the whole issue of counterfeiting in this industry, and then just a brief conclusion on what we discussed for the rest of the presentation. So let's start with an introduction. Really, I just want to get everybody on the same page about what is a patch cord. It's an electrical cable with connectors, simple enough. It's usually constructed with stranded wire for flexibility, but it doesn't have to be. There are some solid conductor patch cords out there. They're used to connect two pieces of equipment together or a piece of equipment to a network. It's the cheapest part of a cabling system and easy to replace. And often because of that, it's the weakest link. There's a lot of time and effort put into horizontal cabling and the infrastructure, and often patch cords are an afterthought, but yet they can seriously affect network performance because all your transmissions don't just go over the horizontal cabling, they go through the patch cords. So some background. There have been a lot of industry studies, probably among the listeners today, a lot of personal experiences with patch cord failures. And these next two slides really just are an overview of some of the studies that have been done over the years. A number of years ago, Fluke Networks had an application bulletin talking about the weakest link in the system. And they found that the study that they did, that 83% of the patch cords failed to meet the prescribed specifications and the ANSI TIA standards. ACTA, back in 2012, had a presentation done by Sentinel Connectors. They found, in some work that they did, that almost 95% of the connectors they surveyed didn't meet the 1096A specification, and 50% actually didn't even meet the gold thickness or nickel plating thicknesses as required by that specification. This has been going on a long time because back in 2003, there was a Quabbin Wiring Cable Company study, and they just randomly picked 96 Category 5E and 53 Category 6 patch cords, tested them for compliance. They were from 34 different vendors throughout North America, and their results showed that 70% of the Cat 5E and 83% of the Cat 6 cords failed. CCCA in 2010 did a study. Their test results showed that there was an 85% failure rate in patch cords that were produced offshore or by offshore companies that were largely unknown. So 78% had failed by more than 3 dB and 45% by 6 dB or more. Category 6 patch cords produced by more recognized manufacturers showed no failure rate. So it was an interesting study. And one thing they wanted to make clear, the CCCA wanted to make clear, that it wasn't the offshore aspect that was the problem, because a lot of the better known companies and well-recognized manufacturers from the United States and North America have manufacturing facilities offshore, and those had no failure rates. So it's not so much the location of the factories or the location of the manufacturing, it's the kind of quality control that they would have, the way they approach meeting industry standards, using low-quality components, things like that. So they want to make that very clear that these things can be made very well any place in the world if a manufacturer chooses to do so. Now let's go through some problems and possible solutions that we've seen with patch cords. One of the first things would be improper assembly. It seems pretty easy to make a patch cord, to put a connector on a piece of wire, but maintaining the integrity of the pair twist, especially as you get into the category 6 and 6A cabling, is critical for good cable performance. Believe it or not, that could be difficult to manufacture consistently, especially in large numbers and with speed, and it does take some skill and patience. So possible solutions seem pretty obvious. Proper training of the manufacturing staff, checking your production, do some production line testing, check continuity 100%, for example, pull samples once in a while to see how things are going. Do quality control inspections of the processes that you have, the manufacturing equipment that you use, products coming off the line, and maybe even doing some surveillance out in the field, which is what UL does for a lot of our programs. Loose connections. This has to do with the dimensional aspect of the plug and jack interface. It results in intermittent or permanent electrical signal failures. Sometimes you plug a patch cord in, it works fine. By the time you dress the cabling and pull the cables a little bit to the side, a loose connection will result in electrical signal failures. Often, or it could be caused by specification itself not being sufficient with respect to the actual dimensions or tolerances. What we've found or heard in the industry at this point is that, in general, specification like 1096, TIA 1096, has real good specifications on the plug, but maybe a little bit wanting on the jack aspect of it. That could result in some loose connections. Right now with patch cords, we're dealing with the plug, so we're in pretty good shape with that, but there is going to be probably some future work on the jack aspect to tighten up the tolerances to make a better connection. Loose connections are also caused by not manufacturing to the tolerances that are there. So even if I have a good specification and good tolerances, if I'm not manufacturing to them, or I'm sloppy with my equipment, dies, things like that, I'm still going to have problems. And just generally poor manufacturing quality control can result in dimensions not being where they're supposed to be, and loose connections and poor signal quality. Best solutions for this is require parts that you're using to meet the appropriate specifications. If you're an assembler of patch cords and you don't make the plugs, make sure you get them from a manufacturer that's meeting the specifications and can prove he meets the specifications. In cases where the specifications are not tight enough, maybe those specifications need to be upgraded, and that's an industry thing. Make sure the suppliers that you're buying these things from have some sort of quality system. We can't emphasize that enough. Quality systems are really everything when it comes to these things. And then last but not least, certification by a third party such as UL or other agencies that are out there that includes some sort of testing, inspections, market surveillance, basically keeps people honest when it comes to these things. This next slide is just an example of the mechanical specification for an 8-pin modular plug that's in ANSI TIA 1096A. Looks very busy. I don't really expect you to be able to read all these tolerances. But a lot of times you look at a modular plug and it seems very simple, very easy to use, but it's actually a pretty complex device because of its size and its capabilities. So meeting these types of specifications is important, and it takes some work if you're going to be manufacturing them. Also in 1096A, there are what they call go gauges and no-go gauges. This just helps prove the dimensions, the overall outer dimensions of the plug. Basically, it has to fit into one and shall not fit into the other. And it gives you an idea that the dimensions have been sized properly in the manufacturing. So this is just a check that's in 1096A. Another problem is the contact material, which basically comes down to plating and design. As Sentinel have found out that in many cases the gold plating is not 99.99% pure, as is required by 1096, or gold is not used at all. Looks like gold, but it's not gold. Sometimes less than the minimum 50 microinches of gold is not provided, or the same thing with the nickel. Thinner gold plating looks great, wears faster. Without gold connections, you have corrosion issues. Sometimes nickel is not used. If you don't have a nickel substrate between the gold and the metal on the contacts, over time the gold will actually diffuse into the metal and you'll lose your plating. And again, that can result in corrosion over time and bad transmission connections. And then once again, poor manufacturing quality control with respect to the plating process or control over your vendor who's doing the plating, providing the parts, enters into it as one of the problems. Possible solutions is use compliant gold plating. Get certificates of compliance from your vendors. Do your own testing, your own checks. Have the manufacturers or the people that are doing the plating actually run tests, provide you with the data as proof that they know what they're doing and providing a consistent product that meets the necessary requirements. You can do electrical and mechanical performance testing. If you don't have the proper gold plating and you do an insertion type test, you can do it to destruction, but if you're doing 500 insertions, 1,000 insertions, without the gold plating, you're likely to see failures. With gold plating, you probably won't have any problems. Also, defining the wiping contact areas. This is something that's important with modular jacks. Because the price of gold is so high, you don't necessarily want to plate the entire contact area. So what a lot of manufacturers do is they provide gold plating where the contact actually takes place. But obviously that requires some diligence in making sure that the plating is in the area of contacts, that it's not drifting because of bad quality control in the manufacturing process. Another problem that we're seeing probably more often now than we have in the past is the cable terminations and the internal connections. The plug's internal solderless connections are often not designed for a wide range of wire gauges that we're seeing today. And people purchase plugs or modular plugs and sometimes don't think about the gauge that's going to be involved with the wiring. It used to be that most of these things were 26 gauge stranded wires. So if I bought a plug from anybody, it was probably good for 26 gauge. Those same plugs may or may not be suitable for 28 gauge patch cord cabling that we're seeing today, or 30 gauge patch cord cabling that we're seeing today. There's also a difference between stranded and solid wiring. Some people are using solid wire, and the solderless connections may be good for one or the other, but not both. So this requires a little bit of work, both from a procurement standpoint, making sure you're getting the proper plugs for the wire gauge that you're using, and also some control of the manufacturing process that people aren't grabbing stuff from the wrong bins based on what kind of patch cords they're assembling. Another problem is the cable diameter. Because of the wide range of wire gauges we're seeing, the cable diameter itself going into the plug is going to vary quite a bit, and the clamping or strain relieving mechanisms may not be appropriate for the different kinds of cable dimensions we're seeing. Again, when you get into category 6 and 6A type of cabling, The traditional squeeze the cable, put a dent in it to make sure that strain relief is going to hold properly is not the best approach. You really want to put more even pressure around the cable to maintain the geometry. And if the cable's not sized properly for the plug or the plug's not sized properly for the cabling, I'm going to have slippage and eventual connection failures. And then sometimes the connections just aren't tested. The connections aren't made properly during the manufacturing process. They're not tested. Sometimes they're not in the proper order. The color coding is not followed, things like that. So again, solutions to this are just proper part selection, proper part maintenance in the factory locations, and then testing the connections, test the individual connections. If you have any doubts about them being able to hold the wires, and then provide proper strain relief and flexing relief at the cable plug terminations. Non-compliant cable is a problem. A bad cable means a bad patch cord. There's a lot of stuff out there where manufacturers make false claims of compliance. They say the cable is a Category 5E, Category 6, Category 6A, and it's not. There's a large industry out there associated with making and selling inferior cables. I'm sure we've all seen copper-clad aluminum conductors. These aren't not permitted by TIA 568, and yet they're out there. You can buy them on the internet very easily. Some of the cables use questionable insulating materials and jackets, and this becomes both a performance and a fire safety issue. Some of us have seen some videos on the results of that. Poorly performing cable marked with a category type designation, or it's just not. It's not even checked. And these are easily obtained all over the place. How do you deal with this? What are possible solutions? Well, make sure your cables are tested for compliance with TIA 568. Make sure they have a category rating. Purchase them from reputable vendors. Reputable vendors are going to carry good quality cabling. And make sure the cablings are certified and verified for performance. There is a difference between a UL listed cable, which has flammability testing, like CMP for plenum rating, CMR for riser cable, and verification for performance. So here what you're looking for is the verification for performance. UL does that, and the top box shows what our certification directory heading looks like. Below that is ETL. They're widely known and used in the industry for verification for performance, and they have a directory of ETL verified cabling products. There are some other ones out there. I think these are probably the two most popular ones. So that's something to look for. The last thing is materials. The materials of the plug itself. Inferior materials could result in dimensional instability, flammability issues. Poor manufacturing controls, not processing the materials properly, having the molding equipment old, outdated, beyond its useful life, things like that affect the material or materials in making a jack. Poor manufacturing processes can affect materials' short and long-term properties. These result in mechanical failures, dimensional instabilities, inadequate electrical performance of the materials, and then flammability of the materials itself. Look for materials that have suitable electrical and mechanical properties. So if you're making jacks or specifying jacks, get something that's made out of good materials. Make sure they have the appropriate flammability and temperature ratings for the use. And when possible, specify certified materials or actually a certified connector, where an agency like UL is going to be actually doing the checking for you. Okay, so the next thing I'm going to talk about is the outline of investigation for patch cords terminating in 8-position modular plug connectors. And this is a performance outline. It's UL 3992. And the next page is really just the cover page from the published outline of investigation. A little bit of background on this. We worked very closely with the CCCA on this particular standard. And what the CCCA was looking for was a specification that was not too onerous, such that nobody would use it, but yet had enough meat in it where you could rely on a patch cord that meets the requirements to actually do what it's supposed to do from a transition standpoint. The objective was to have a specification that an organization, a company, a government body could refer to in their procurement specifications that would allow them a single place to go to just to get good quality patch cords. So that was the objective of this thing. The idea was to have a standard that someone who's buying for a company can say, I want my patch cords that we're going to be using in the computer center to meet UL 3992. Very simple, very easy to check. So that was the objective behind this. The other objective from a UL standpoint in developing this with the industry and getting feedback from the industry on this was to address the problems and include the solutions that we just went over in the previous slides. So just a brief rundown of what's in the specification. As I showed the drawings earlier from TIA 1096A, the outline requires the mechanical dimensions and contact specifications that are in TIA 1096A. In this case, there's no reason to reinvent the wheel. 1096A has been around for a long time. A number of manufacturers have verified that things like the dimensions and the gold plating requirements are valid, useful, makes sure that the quality and the plugs are going to be there, so we just use those. The gold finish and the plating processes and the verification also come from TIA 1096A. There's the requirements for the type of gold, the thickness of the plating, the nickel base material, things like that. The solderless connections is an interesting one. There's a number of IEC standards that deal with all the different types of solderless connections that you might see. And what we found was that from a manufacturer's standpoint, it's a good idea to use those specifications, but the testing that's involved and the evaluation that's involved in meeting all of the requirements was just too onerous for what we were trying to do with the specification. So although it's not a bad idea for manufacturers to go through the IEC documents and go through the entire program when they're designing plugs for this use, we decided that we would use a pull-out force test that's in that specification. Assuming that there has been work done on the connection aspect already, this pull-out force test verifies that the connections are solid, that the connections are appropriate for the type of cabling that's being used. The flame rating on the material, the V1 material, or a 12 millimeter component flame test. This is a requirement that's been around going back to the telephone modular jack days. The V1 material is derived from the requirements in end product standards, such as UL 6950, UL 62368. If you look at how they approach the requirements for connectors and how these connectors are used in low voltage circuits, V1 material will be appropriate. So we really just adapted it from those specifications, because that's the most common use for patch cords, is with IT and communications equipment. From a cord cable mechanical performance standpoint, we rely on TIA 568-C2. For category performance, same thing. So the requirement for patch cords is found in TIA 568-C2 is applied. That's part of the checking process. Make sure the cable meets and continues to meet 5E6, 6A from that standard. There's a strain relief test. It's about 11 pounds or 50 Newton force. That's applied from the cable. See if we can pull out from the plug. Flexing test. In earlier UL standards, like UL 1863, there was not a flexing test. And yet we find out, especially as we go into lighter gauge cabling, that flexing is one of the areas where there's a lot of failures with patch cords. So the flexing test was adopted from the IEC document, or there's a separate flexing test that was adopted from UL 588 that's actually in 3992. So there are two options, and this is one of those cases where, depending on where you are located in the world, what kind of test setups you might have at your facilities, these are two tests that are similar, but not exactly the same, but either one proves or whether or not a cable can withstand a certain amount of flexing without pulling out or damaging the connections. There's a mechanical operations test, basically 750 mating cycles. There's no electrical load applied. This is strictly a physical mechanical test. Dielectric voltage withstand test of 1,000 volts AC between the pins and between the pins and any grounded or shielding that might be associated with the jack. And then the standard also requires a continuity assembly check on 100% of production. Believe it or not, as I mentioned earlier, this seems to be one of the biggest areas of patch cord failures or patch cords not working, is that they're just not assembled properly. Continuity checks are done by a lot of manufacturers. They're easy to do, and it gets rid of a lot of the bad product at its source very quickly. Verification. Why would you need verification? I'm sure that any manufacturer out there does a certain amount of verification on the products that they buy, the components that they source. But verification is important from the standpoint of your customers or someone's customers knowing that they're getting what they're specifying. So I could specify that a patch cord meet UL 3992, but how do I know it really meets UL 3992? Well, the verification process, just like the category verification process, provides some assurance to you and the customers that a product actually meets the specified or the claimed requirements. This is an example of the UL patch cord verification program. We describe our certifications in what we call guide information. There used to be index cards, so people still refer to them as guide cards sometimes. This is only a partial picture of what it looks like. The category code is DVBH. Those of you familiar with UL know that we use these 4-letter codes that don't seem to have any rhyme or reason behind them to identify the categories. And the category name is Communication Cable Assemblies, verified for data performance in accordance with national and international specifications. In this guide information, there's a reference to the standard UL 3992 being the standard of choice for this category. The verification not only goes through the test program to see if the patch cord meets the requirements, after both some electrical and mechanical abuse, but it also includes factory follow-up, where inspectors or follow-up representatives, surveillance representatives will actually go into a factory, look at the product being made, inspect it according to reports that engineering writes, looks at the quality systems in some cases, depending on the type of product that we're looking at. But there's a focus on quality, making sure the factory has some quality systems in place, knows what they're doing, and can consistently make products in accordance with the standard. Second part of the verification program, as far as the way UL operates the verification programs, is market surveillance. We actually go out and purchase products. Could be big box stores, could be on online sites like Amazon. We take those products, bring them into the laboratory, and we run certain tests on those to see if they comply with the requirements. This type of market surveillance is the type of surveillance that was done in the earlier slides where I showed that the CCCA had done some work and some other manufacturers. That's the type of market surveillance we're talking about, and we do that as part of our verification of the product. The last thing which UL is very involved in is anti-counterfeiting. Our mark, just like any trademark, because it's well known, because it's well respected, gets counterfeited. There's no doubt about that. UL has an extensive anti-counterfeiting program, basically to protect our mark, to protect the integrity of the products that bear our mark, and I'm going to go into that just a little bit more on the next few slides. So let's talk about counterfeiting. Why is it a problem? Well, it's a problem because there are dishonest manufacturers out there. There are disreputable dealers and distributors out there. Generally, there's a lack of inspections, especially with patch cords. People look at them, again, they're easy, they're cheap, you can buy them any place. I could buy them in bulk at very low costs. Inspections cost money. Generally, if something's too good to be true from a cost standpoint, it probably is too good to be true. Those products are not being inspected, not being checked. If you have a certification program, but you don't inspect the factories, you don't inspect the distributors, that creates a problem. Often there's a lack of market surveillance as far as checks and testing. In the electronics industry in general, there's a lot of trademarked symbols, Wi-Fi, USB, HDMI. They're trademarked, they're registered trademark, they're copyrighted. But unless you go out there and police it, those things get misused and abused. And the lack of market surveillance just promotes that type of illicit activity. And that ties in with the soft control of the certification marks, where you have a certification mark, you say you control it, but you don't really. The disreputable people see that right away and will definitely abuse it through counterfeiting. Possible solutions. One is to use an organization, certification organization, like UL, or in the case of category like ETL. Look for things that are third-party certified. That third-party certification means that organization is inspecting the products, they're doing market surveillance, and generally they have a reputation associated with their mark, so there's good mark protection. Know your suppliers, know your customers, know your distribution system, and make sure those people are educated what to look for. Putting that something is verified or certified into a procurement specification, but not checking it once in a while and not having your suppliers or customers understand what that means, really softens the whole process. So education of the whole supply chain is very important. Make sure that the procurement people and the purchasing people, suppliers, know what the certification marks look like, what they're supposed to look like, and what they mean. Again, I talked about UL listing from a safety standpoint versus UL verification from a category performance standpoint. If you're buying cabling, the people who are buying it and specifying it should know the difference between those two and know what to look for. Know how to identify a fake mark. I'll give one example of that in the next slide. And don't buy cheap. If you buy cheap, if it's too good to be true, it probably is. The cheap stuff, the label that's on the bottom over there came off a cheap product. It's got a UL and a circle on it. That particular label is not appropriate for communications cabling. It's a counterfeit label. It's a counterfeit mark. People in the supply chain should know that. At UL, in categories such as communications cable, we use holographic marks. Within the holographic mark, there are a bunch of different codes and things that can be looked for. One of the most obvious is what we call an authentication. We have these little tabs that we call authenticators. If you look at the label above the authenticator, you'll see it looks like a black dot. That's part of the holographic label. When I put the authenticator over it, you'd see the UL come out from that black dot. Usually it's not a UL, it'll be some sort of a code, a letter, a number. If you don't see that type of change using the authenticator, then that holographic label is probably counterfeited. Within that circle and the authentication, there's a code, and you can always contact UL if you have any doubts about the code being valid, and we can determine if the code is appropriate for the product in the time frame the product was sold. So that's one method that UL uses for authenticating certification marks. We use these types of marks and holographic labels in areas where we have identified huge problems with counterfeiting. So this is a step up from the standard paper label, and it's used in areas where we know there's a lot of counterfeiting going on as an attempt to curb that as much as we possibly can. So I think we're doing pretty good with time, and I just want to go over some conclusions that we've gone over in the presentation today. Remember, patch cords are a critical part of the network. Even though they're often overlooked because of low cost and easy replacement, the transmission goes over them just like it does the rest of the cabling. So don't overlook them. Trial and error approach, which a lot of people seem to use sometimes. I'll buy a box, they're cheap, they look okay. I'll plug it in, see if it works. If it doesn't, I'll plug another one in. That's a lot more time consuming and expensive than you might think. The other downside to that type of approach is I can try it and it'll work, but it may not be performing at the speeds that you anticipate. So if I'm in a range of where I need a 6 or a 6A cabling and the cable's not performing at a 6A level, it might still work, or I'm not going to get the speeds out of it, and I might not notice that for a long time. System failures can be devastating. It's a shame if I have a critical system like an air traffic control or a banking system that fails to perform the way it's supposed to because of a patch cord. Look for appropriate specifications. Specifications have to be developed together with the industry, and that's where UL 3992 came from. But the specification has to be followed. Manufacturers of both the plugs, the cabling, and the final patch cords have to follow the specifications. Someone's got to verify that people are doing it, because if you don't verify it, people are going to make claims that are just not true. And the final thing is to make sure that the customers specify the appropriate specifications. So in procurement specifications, it's good to actually identify the specification. You can't just say, I want a good patch cord, or I want a category 5E patch cord. If I want a verified patch cord, the specifications should say, I want a verified patch cord that shows it meets UL 3992. So thank you. That's all I have for today. I'm sure there are a whole bunch of questions that came in that I'll be willing to answer at this point. So,
Randy,
yeah,
I'm going to pick up the ball right here. I do have a few.
Okay.
And I'm going to start off with our first one here. With such a high, greater than 80% failure rate of patch cords in studies by Fluke, CCCA, and others, how come there has not been a stronger outcry from users about the seriousness of this problem? Are people just not aware, or is this a new problem?
Well, it's not a new problem, because the studies, one of the studies goes back to 2003. I think a lot of times, because of the price and the way these things are bought, they see the problem. If it doesn't work, they just put another patch cord in. Or the patch cord works for a time when I first install it, but then if my gold plating is bad, you're going to have failures down the road. So you're not going to be tracking those as carefully as you might. And the last thing, like I said, a lot of times if the patch cord doesn't meet the specification, the system might work. It may not work up to the performance that you want it to, but it'll work. And it may not be obvious for a long time that the patch cord is bad. And the CCCA, I think the CCCA is doing some additional studies now, so we should be getting some new information on it.
Okay. Are there adequate substitution materials to gold plating of connector contact points? With these alternate materials, is workmanship and assembly procedures even more important?
Yes, actually 1096 does have an alternative process for looking at plating processes other than gold. That is included in 3992 as an option. It's a little bit onerous. I know manufacturers who have done it in the past. It involves things like mixed flowing gas, corrosion testing. I think the ultimate processes are probably very similar to the controls you need for gold plating. It's more the upfront process that's a little more involved because of the aging and corrosion testing that's done for the alternate materials. But it is in 1096. It is referenced in 3992, and it is an option for manufacturers who want to use it.
Okay. Next, can short-length patch cords adequately transmit Cat5e, even if not fully compliant with the standards? Is the high failure rate now important with the higher bandwidth requirements of 6A and beyond?
Yes, certainly the manifestation of problems is going to be more apparent if I need a 6 or a 6A cabling. Short cabling can meet 5E. I'm not really one of the UL experts on transmission characteristics of the cabling, but usually when we test cabling to the standard, we would ask for the longest length that a manufacturer makes and the shortest length, because both are going to show problems in a different way. But ultimately, it's best by test. So rather than say a short cable is good or bad, send it in. We'll test it and we'll let you know.
Okay. I think this next one's related. Cat 6A or higher transmission over short lengths can be made with inferior cable designs that would not necessarily pass over 1,000th lengths. Should certifications for patch cords be the same as for a network cable?
I think that's probably something the TIA should take up. Right now, their requirements for testing the patch cords, some people would say are pretty minimal. We were in developing 3992 had no intention to buck the industry trends and buck the experts at the TIA. I think that's an excellent topic to bring up, and it's probably a good time in the industry to bring that up, given the higher demands that are placed on cabling systems, the high speed 6 and 6As especially.
Okay. Do you think that the same failure rate of greater than 80% for patch cords is the same in all regions of the world, or is this a regional problem in the USA?
I think it's probably at least as bad in other regions of the world. I think in the USA you have organizations like UL and ETL and IWCS and CCCA that are identifying the problems, that are trying to get some awareness out there. And there are probably parts of the world where you don't have that happening, where price is everything. So I'm looking for the absolute lowest cost, the cheapest thing I could find, and that's where you're going to find these kinds of problems. I think what the CCCA study was really an eye-opener in that, if I have a good supply chain with reputable known manufacturers, I don't have a problem. And I think what this whole verification and development of 3992 was intended to do was to sort of raise the bar up to the level of those reputable manufacturers, such that I can identify a product that might be suspect. So a reputable manufacturer is going to meet 3992, a disreputable one won't be able to meet it, and now I can look at that cable and look for verification and determine that very easily, as opposed to just looking for a marking on a box or a description on Amazon.com.
Okay. Next, how do we get retailers such as Best Buy, Lowe's, or other electrical product distributors to specify a certification program to assure compliance to all safety and performance standards for patch cords?
You go talk to them. UL actually has a group that's their main purpose in life is to go to both online and big box retailers and bring to them different programs that we have, either related to safety or more and more related to performance, and discuss with them, the problems that we've discussed here, why they should be interested in something like a verification program, how it raises the integrity of the product that they're supplying and their own distribution of those products. So we have a group that goes out and does that. We certainly encourage, any of the organizations or any of the manufacturers to do the same. A lot of times manufacturers have tie-ins with these companies. If they want to help raise the bar, the more people than there is, the better off we'll all be, I think. But UL does that on a regular basis with these types of programs.
Great. Thank you. That concludes our Q&A period. Thank you, Randy, for presenting this very interesting and important topic today. Please note the contact points being shown should you wish to contact Randy after today's event. Each of these IWCS webinar series presentation events are recorded and will be archived on the IWCS.org website. It normally takes up to 2 weeks for these to be posted. The IWCS webinar series will conduct presentation events on a monthly basis. Webinar events will take place on the third Friday of each month at 10:30 a.m. Eastern USA time. Our next scheduled webinar event will be Friday, May 19th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for the event a few weeks prior. Please feel free to share our announcements with your colleagues so they can join in and register as well. For over 65 years, the IWCS International Cable and Connectivity Symposium has been the recognized leader showcasing new technologies in cable and connectivity products, processes, and applications. Our next annual international conference will take place on Sunday, October 8th through Wednesday, October 11th, 2017, at the Gaylord Palms in Orlando, Florida, USA. In addition, the inaugural regional UL and IWCS China 2017 Cable and Connectivity Symposium will take place on Tuesday, April 25th through Thursday, April 27th, 2017 at the Marriott City Center in Shanghai, China. Please visit our website at iwcs.org for more event details. In just a moment, you will see a brief survey so that you can provide us your feedback and comments on today's event so that we can further improve this webinar series for you. Thank you for participating, and this concludes today's event.